Hey guys, we're going to look at basic differentiation rules today. So the first one is the derivative of a constant rule. The derivative of a constant is 0. Remember, derivative and slope are the same thing. So if I have the slope of the graph of a constant, it would just be a line that is horizontal. And the slope of a line that's horizontal is always going to be 0. So the derivative of a constant is also 0. The second one we're going to look at is the derivative of a function with x raised to a power. So like right here, x to the power of n. Our shortcut rule, so we don't have to use the formal definition every time, is n, so that power, times x to the power minus 1. So the power goes down by 1, and the power is also multiplied out in front. So let me show you how this works. So we have x to the 5th. Well, my power is 5, so I'm going to do 5 times x to this power minus 1. So really this is 5x to the power of 4. So the power goes down by 1, and the original power is multiplied in the front. Here we have 1 over x to the power of negative 2. So in my opinion, I would say that it is easier to think about this as x to the power of negative 2. So remember, that is the reciprocal. Whenever I bring this up to the top, it's a negative exponent. So now the exponent's negative 2, that comes out in front, times x to the power minus 1. Well, negative 2 minus 1, so that gets me negative 2x to the power of negative 3. Now I don't really want my final answers to be negative exponents, so I would want to write my final answer as negative 2 over x to the power of 3 like this. So let's actually write this in derivative notation here and in derivative notation here. So we know that that's what we were doing, not just doing random math here. So the derivative of this one, again, I'm going to say that this form is not as easy to think about as exponent form. So if I take this to exponent form, the number inside is my numerator, the root that I'm taking is the denominator. So now I can follow my power rule to take the derivative, which would be the power comes in front times x to the power minus 1. Now we have to think about 2/3 minus 1. We need common denominators, so this, just a little side note, is really the same thing as doing 2/3 minus 3 over 3, because we know that 3 over 3 is the same as 1. So now I can do 2 minus 3 on the top, and we get 2/3 x to the power of negative 1/3. Again, we don't want to have negative exponents in our final answer, so 2 is the numerator, 3 is the denominator, the x is going to jump down to the bottom. You can leave it in this form, or you could write it as 3 and then cube root of x. Either one of these mean the same thing. Now our constant multiple rule is next. If a differentiable function and c is a real number, then cf is also differentiable. Okay, so this is just multiplying. Okay, we have a constant in front. All of these were just x's that we dealt with up above. This one has a coefficient in the front. So it's going to follow the same rule. We just have a 3 that we have to deal with first. So 3 times the derivative of this, which would be 2x to the power of 2 minus 1. Well, 2 times 3, that's 6. And then x to the power of 1. You can write the 1 or not. It doesn't really matter. So that coefficient is really just following along, and we multiply with it. So this one right here we can write as 2 times x to the power of negative 1 if I bring that up to the top. So then we just follow our differentiation rule. We have 2 times, now take the derivative of this, negative 1, so I'm actually going to put parentheses around that, times x to the power of negative 1 minus 1. We want to bring the power down by 1. 2 times negative 1, that equals negative 2. X to the power of negative 2. Well, the negative 2 is going to stay on top. To bring this as a positive power, we want to bring it to the bottom. So we have negative 2 over x to the power of 2. Last one is kind of like the one that we did up above. First, I want to say that this is 3x to the power of 3/5. So now we can take the derivative by doing 3 times, that power was 3/5, x to the power of 3/5 minus 1. 3/5 minus 1, that's 5 over 5. So we have x to the power of negative 2/5 right there. Multiply this, remember top times top, bottom times bottom, so 9 over 5 right there. I want to make sure that I don't have a negative exponent, so let's fix that. This x is going to come to the denominator with the 5, and it's now a positive 2/5. Or you could write it in the root form, which would look like this. 9 over 5, and then it's a 5th root of x squared, like that. Looking at the next rule, we have sum and difference rule. We're just going to take each derivative individually. You just take each one. So if I want the derivative of a polynomial, just take each individual derivative. So hopefully we're getting a shortcut of not having to show the work by now. So the 3 comes in front, and then drop the exponent by 1, so 3 minus 1 is 2. Going on to the next one, the derivative of that, the 2 comes out front, x, drop that power by 1, so 2 minus 1 is 1. You don't have to do a power of 1. And then this is a constant. Remember, the derivative of a constant is always 0, so I don't have to write that. So that's the derivative of this. Looking at this one right here, I do want to rewrite before I get started because I don't want this in the denominator. I want to see what its power is with everything on top. So 3x to the 5th minus 2x to the 3rd plus x to the power of negative 1. Now that I have this, I can do my derivative of each individual. Well, 5 is going to jump in front. 3 times 5, that's 15. Now bring the power down by 1, so it's x to the 4th. Here, we've got negative 2. The 3 is going to come out front and multiply, so 3 times negative 2 is negative 6. X to the power of, bring it down by 1, so 2. Last one, we have plus. My power comes out front, so that's negative 1 times x, bring that down by 1, so negative 2. Make this look a little bit nicer. We don't want negative exponents, so I'm going to go 15x to the 4th minus 6x squared plus and a minus, that's really minus 1 over x squared, like that. Derivative of sine and cosine. These are ones that we want to make sure that we just have memorized. The derivative of sine is cosine. The derivative of cosine is negative sine. So these are ones that we want to make sure that we have memorized so we can use them. So derivative of sine is cosine. Derivative of cosine is negative sine. Looking at this one, if I take the derivative of this, the 2 is just that coefficient, it's going to follow along. The derivative of sine is cosine, so my full derivative is 2 times cosine x. Here, that 1/2 is just going to follow along. The derivative of sine is cosine, so we have half cosine x. Last up, we have the derivative of x plus cosine x. So these are added, so we're going to take individual derivatives. So the derivative of x, well, the power is 1. So if I want to take the derivative here, I've got 1 times x to the power of 1 minus 1, which is 0. So we have x to the power of 0, which is just 1, so the derivative of x is 1. Plus, we have the derivative of cosine. Derivative of cosine is negative sine, so we have 1 minus sine x. Next, we have a horizontal tangent line. Horizontal tangent lines have lots of applications. You can find where a function has a horizontal tangent line by taking the derivative of the function and then setting it equal to 0. What this does, a horizontal tangent line needs to look like this. And we know that that horizontal tangent line needs to have a slope of 0, so the derivative slope needs to equal 0. Okay, so let me show you how this works. For what values of x do the following functions have horizontal tangent lines? Well, take the derivative first, because derivative is slope. So 3x squared. The 2 comes to the front. 3 times 2 is 6. X, bring the power down by 1. 2 minus 1 is just 1. Next up, we have negative 2 times the power of 1, so that's still a negative 2. And then x to the power of 0, that's just 1, so that's gone. And then the derivative of a constant is 0. That's gone. So this is our derivative right here. So to find where we have a horizontal tangent, the slope must equal 0. Slope and derivative are the same thing, so 6x minus 2 needs to equal 0. Add the 2, so 6x equals 2, and x equals 1/3 when I divide by 6. So the place where we have a horizontal tangent on this function, f of x equals 3x squared minus 2x plus 1, is at x equals 1/3. Next up, we want to find out where cosine has horizontal, or negative cosine has horizontal tangents. So derivative of negative cosine. Well, we got to consider the negative. The derivative of cosine is negative sine. Negative and negative turns positive. So my derivative is actually positive sine. Where we have a horizontal tangent is where that slope, where that derivative is equal to 0. So we say, okay, sine of x, where is that equal to 0? Well, if we think about all the places on our unit circle where we have 0, starting at the beginning, the value of sine at 0 is 0. So x can be 0, and then I go around my unit circle, and pi also has sine of 0. And then I keep following the circle, 2 pi, 3 pi. And it's just going to follow that pattern forever and ever and ever. So each one of these, we have a horizontal tangent line of 0.